So we have letter number C. Find all values of x on the interval -4 to 3 for which the graph of g has an inflection point. We got that the graph of g equals 2x plus the interval, definite interval from 0 to x of f of t dt. So if you want the points of inflection of g, we need to find a point on which the second derivative equals to 0, or where the first derivative has either a minimum or a maximum. So first of all, we make the derivative u prime of x equal, we derivate 2x is 2, the definite integral by the second term of calculus, we got that is plus fx, and this is the first derivative, and then we need to get the second derivative. We need 0 second derivative, so we got that the second derivative of g equals to 0 plus f prime of x. So we need to find the point where f prime of x equals to 0. As we recall, this is the graph of f. So what does f prime of x equals to 0 means? It means a point where f of x equals either a minimum or a maximum. And just by looking at the graph, we look that we have a maximum at x equal to 0. So by this we can conclude that y has an inflection point at x equal to 0. Okay, so then we have letter number D. Find the average rate of change of f on the interval -4 to 3. Okay, first of all, if we want to have the average value, we know that average value equals from 1 over b minus a, definite integral from a to b of f of x dx. Okay, if we want the average value of the rate of change, we have to derivate, right? And we have to derivate f. So f prime of x, we will working with it, and if we apply the formula, we will get 1.
Mamá tiene muchos ojos prendidos.
¡Cholotín! ¡Carajo! ¡Estoy grabando algo!
No me grites, yo no soy adivino.
Gracias, güey. So we will be working with this formula. We have f prime of x, and if we apply the formula, we got that 1 over 1 3 minus 4, definite integral from -4 to 3 of f prime of x dx. If we apply again second term of calculus, we got that 1 over 7 minus become plus, 3 plus 4 equals 7, 1 over 7 f of x. Okay, so we got that 1 over 7 f of x from -4 to 3, and if we substitute 3 and -4, we got that f of x at the point 3, just by looking at the graph, it's -3, and f of -4, just by looking at the graph, is -1. So -3 minus -1 becomes -2 times the 1 over 7 that we got here, and we get -2 over 7, that is equal to the average rate of change. All of this is the formula of second term of calculus. This equals to the average rate of change. Okay, and there is no point C on -4 to 3 for which f prime of c is equal to the average rate of change, because to have the mean value term we need the function to be both continuous and differentiable. And we can see just by looking at the graph again that of course the function is continuous in the interval -4 to 3. But as we can look here and here we have a vertical line, so it is not differentiable. And we also get here that of course it is not differentiable too, so that will be the answer from point D. It does not contradict because the function is not differentiable at x equal to 0 and at x equal to -3.
Iván Poblette and me are going to solve the exercise number 2, which states that the continuous function f is defined on the interval -4 to 3. The graph of f consists of 2 quarter circles and 1 line segment as shown in the figure above. Let function g equal to 2x plus interval from 0 to x of the function of f in terms of t. So the first things it asks is to find -3 on the function of g. So we get this by substituting. First 2 times -3 plus the integral from 0 to -3 function f in terms of t. But in this case we need to invert the integral since -3 is less than 0. So this will be -6 minus the integral from -3 to 0 of the function in terms of t. So with this we need to check the graph again and see the interval from -3 to 0, which is a quarter circle with radius 3. So by using the formula of the quarter circle, which is the square radius times pi over 4, by substituting we get 9 pi over 4, which equals -13.068, and that's the first. This is the first solve. Then it asks to get the derivative of g. So g prime x is equal to 2x, derivative of 2x, it's 2, plus, by getting the second theorem, the derivative of this one is 1, and getting it into the function is, we get f of x. So this is the derivative of the function g. And then it asks to get -3 on the derivative of g to evaluate, and then so we now substitute, so it will be 2 plus -3 in the function of f. And with this we need to check again the graph and see it. So -3 in the graph is 0, so this will be 0 and the answer is 2. The second one asks to determine the x-coordinate of the point at which g has an absolute maximum. So to do this, first we need to equal the g derivative to 0. So this will be 2 plus function f equal to 0. So then function f is equal to -2. So we need to check where in the graph where x is equal to -2. So we need to get this by getting the equation of this line. So you get first y is equal to, by the side it is going, it is negative, and to get the slope we see it goes 3 down and 1.5 to the right. So 3 over 1.5 is equal to 2 minus 2x plus the y-intercept, which is 3 plus 3. So we need to equal these 2 minus 2 to get the absolute maximum. So first we get minus 2x is equal to minus 5. Solving this, we get x equal to 5/2. So this graph has an absolute maximum at the x coordinate 5/2.